The moon is one of the most underappreciated forces in our sky. It's always just there, steady and reliable. But what if, one day, you looked up and it was gone? That single disappearance would completely change everything we know about our planet. In this video, we'll explore the science and uncover the very real consequences of a world without its moon. Before we consider its absence, we must understand its presence. The moon is not just a passive observer. It is a critical force that shapes our planet in several key ways. First, it controls our tides. Second, it stabilizes Earth's axial tilt, which gives us seasons. Third, it slows down our planet's rotation, governing the length of our day. Fourth, it acts as a shield against space debris. And finally, it helps maintain Earth's climate and ecosystems. Let's begin with tides. This is the most visible effect of the moon. The moon's gravity creates a gravitational force that pulls on Earth's oceans. This pull forms bulges of water on both the side of Earth facing the moon and the opposite side. As Earth rotates, these bulges create the predictable rise and fall of our tides. It is a constant rhythmic dance between Earth and moon that defines our coastlines and ocean currents. Earth spins on a tilted axis, approximately 23.5 degrees. This tilt is the reason we have seasons. The moon acts as a gravitational anchor, like a gyroscope, that keeps this tilt stable over millions of years. Without this stability, the Earth's axis would wobble dramatically, known as precession. This wobble would be catastrophic for our climate.
This is fine.
The moon is also responsible for regulating Earth's rotational speed. Billions of years ago, a day on Earth was only about 6 hours long. Through a process called tidal braking, the moon's gravitational pull has been gradually slowing Earth's rotation, extending our day to its current 24 hours.
The moon is more than a silent companion. It's a cosmic bodyguard. Its heavily cratered face is proof of countless collisions with asteroids and comets that could have struck Earth instead. The moon's gravity alters the paths of many incoming objects, deflecting them or capturing them. Without it, our planet would have faced far more frequent catastrophic impacts. In short, the moon takes the hits so we don't have to. The moon's influence goes beyond tides and impacts. It helps stabilize Earth's entire climate system. Its gravitational pull keeps our axial tilt steady, which in turn keeps seasonal patterns predictable. Meanwhile, lunar tides drive ocean currents that distribute heat around the globe, preventing extreme temperature swings. This delicate balance has allowed ecosystems to evolve and thrive in relative stability for millions of years. The first changes would unfold in our oceans. Without the moon, powerful lunar tides would collapse overnight, replaced by weak, irregular solar tides. Coastal rhythms would break down, breeding cycles would falter, and marine ecosystems would be thrown into chaos. The rapid and extreme climate changes would trigger a mass extinction event.
Oh, wow.
Species that have evolved to live within a stable climatic window would be unable to adapt to the dramatic and rapid temperature swings. Animals and plants that rely on lunar cues for migration, mating, and other behaviors, such as coral reefs and nocturnal animals, would lose their rhythm. The biodiversity of our planet would be severely diminished.
What?
The absence of the moon would halt the process of tidal braking. Earth's rotation would no longer be slowing down. While the change would be imperceptible in a human lifetime, over millions of years, the length of the day would stabilize at its current duration rather than continuing to lengthen. With the moon gone, our night sky would be shockingly dark. No soft lunar glow, no familiar phases, just stars and the occasional planet. But this darker sky comes with a hidden danger. Without the moon's gravitational influence, more asteroids and comets would make their way toward Earth unchecked. Over time, the frequency of major impacts would rise. The moon's cratered surface once absorbed countless blows. Now Earth would take them directly. Some scientists speculate that the moon's gravitational pull exerts a subtle tidal force on Earth's solid crust and mantle, contributing to geological activity. While this effect is minor compared to internal forces, it's possible that the absence of the moon could lead to changes in tectonic plate movement or seismic activity. However, this is a topic of ongoing scientific debate and is not as well understood as the other effects. To appreciate our situation, we must briefly revisit the Moon's origin. The most widely accepted theory is the giant impact hypothesis. It suggests that a Mars-sized object, Theia, collided with a young, molten Earth. The debris from this collision was ejected into orbit and eventually coalesced to form the Moon. Our Moon is not just a captured object, it is a direct result of a planetary formation event that made our planet what it is today. How do we know all of this? Scientists rely on complex computer models and simulations. These models use real data from NASA missions like the Apollo and Artemis programs to predict the physical outcomes of a moonless Earth. These simulations are our only way to study such a catastrophic event, allowing us to understand the delicate balance of our planetary system without having to experience the consequences. If the Moon were to vanish, humanity would face an existential crisis. The scale of the environmental changes would be unprecedented. Our current infrastructure, food production, and societies are built on the assumption of a stable planetary environment. We would be thrust into a battle for survival against a rapidly changing planet, a challenge that would make all other historical crises seem minor. Beyond its role as a stabilizer, the Moon is also a crucial stepping stone for future space exploration. It is our nearest celestial body, a place to test technologies and build a permanent presence in space. Without it, humanity's journey to becoming a multi-planetary species would be far more difficult and costly. The Moon is a gateway to the solar system, and losing it would be a major setback for our cosmic aspirations. In conclusion, the what-if scenario of a vanishing moon is more than just a thought experiment. It highlights the immense and often unappreciated importance of our celestial partner. It shows us that life on Earth is supported by a fragile and complex balance of cosmic forces. The Moon is not just a distant rock, it is a vital part of what makes our planet a haven for life.